Okay, so let's say, for example, I have a question regarding recent event, and let's see how ChatGPT responds. So I'm going to ask that, for example, let's type it, was recent attempt of SpaceX to launch Starship successful? Yeah, something like that. Starship successful. Okay, let's see how does it respond. Okay, so there is a disclaimer. It says it cannot answer that. However, as my knowledge, date 2021, SpaceX has made several attempts and so on and so forth. So it doesn't have that knowledge of this. Of course, we can ask the same question from Bart, and let's say whether Bart would respond or not. Okay, so I'm going to Bart. Let's copy it from here, exactly the same question. Say no, the recent attempt of SpaceX was not successful. So it has actually the information. It's more like a Google search right now. In fact, you can say Google it, and the Google it actually provide some information, some links to the reality. Okay, but let's imagine that you want to ask a question that you cannot find the result on the web. So here, actually, the model by itself probably doesn't know it, but when it doesn't know it, it actually refers to the search engine to find it. Okay, but imagine that, let's say, for example, you ask a question, but you have a database that you know that in that database, the answer resides in the database. And you want to find the answer from one of those answers. How do you go to design such a system? So in a conventional search, we try to match keywords. So for example, looking for any response which has a SpaceX, or let's say a Starship, or maybe successful or failure or something like that. But that's typical. But the problem is that, let's say for example, if you want to find your answer, let's say here, which I search for SpaceX articles, and let's say this is your answer. You probably won't hit this one because there are others which has, both Starship and SpaceX, and this one doesn't have. So the idea is you need to go beyond keyword search, and you need something called semantic search. So that means that, for example, if you go to here and take your query, this is your question, and pass it through basically this encoding, it turns to a vector. And if you take all of these articles, it can be the whole article, it can be a document, it can be just a sentence. You can pass all of these through encoding, and then you get also vectors for that. And for example, if I look at here, this is your question, and these are all these articles. And then you can find the closest articles to your question, and you will find your answer there. So in a way, you will find it that this, let's say for example, let's go back to the search result. You will find that this vector is actually closer to your question than, for example, let's say this vector, or something which has the Starship in it. So that's the idea of the vector search. That's pretty actually straightforward. It's the easiest way to inject the intelligence of language models into your vector search and create basically a semantic search, an intelligent search. So we will talk about that, how we can use tools which are available open source for this kind of a vector search.